We're going to continue discussing Chapter 8. This video is going to focus on Section 9.3, mole to mass calculations. And so in the last video, we talked about moles of known converting to moles of desired, so the area focusing on the red right in the middle here. What we're going to be looking at in this video is looking at going from moles to grams. So let's look at our problem. It's going to sound very similar to the ones we talked about in the last video. What mass of hydrogen can be produced when 6 moles of aluminum reacts with HCl? Now, the first thing we need to remember is that everything we're going to be dealing with always needs to go moles to moles. So when we start these problems, they're going to be exactly like our last problems. Our first step is going to be looking for our molar ratio. So in this case, we're going to go from moles to aluminum to moles of hydrogen to grams of hydrogen. So our two conversion factors we're going to need are our molar ratio, which we got from the balanced equation. So 3 moles of H2 with the coefficient of hydrogen, 2 moles of aluminum, the coefficient of aluminum, and the molar mass. Now remember, the molar mass of hydrogen, since it's diatomic, is 2 hydrogen atoms, so it needs to be 2.016 instead of 1.008. So we'll start with what's given in the question. Again, look for the number and the unit given in the question. So 6 moles of aluminum multiplied by our molar ratio, the coefficients of hydrogen and aluminum. Our moles cancel, and that's how we know our moles of hydrogen needs to end up being on top. Then we're multiplying by our molar mass conversion factor, so our moles of hydrogen will cancel out, giving us 2.016 grams on top as our molar mass, giving us 18 grams of hydrogen. So remember here, we need to keep in mind significant figures, so that's why we have 182 sig figs when the question gave us 6.0. Here's another example that you should try now. Remember, start with the number given, use your molar ratio, and then your molar mass. Pause the video now. Okay, so for this one, we're going to be going from moles of silver sulfide to moles of silver nitrate to grams of silver nitrate. So here are our ratios, and if we look at our balanced equation, we know we're going to get the coefficients for our molar ratios from our coefficients, and the second one is the molar mass of silver nitrate, 169.9 grams. Remember, we got that number by adding up the molar mass of silver, nitrogen, and don't forget we have 3 oxygens here, so that's how we're getting about 170 grams. So we'll again start with 0.25 moles, use our molar ratio to get into the desired compound. So our moles of silver sulfide will cancel out, our moles of silver nitrate will cancel out, and we're left with 85.0 grams, and in this case I've added an extra 0 there. It should just be 85 grams. That's it for section 8.3.